Good morning. Today, our lesson begins with 5.3 solid. These are the learning outcomes that we will cover under solid. First, we look at the properties of solid. Fixed shape of a solid. Intermolecular forces between solid molecules are strong enough to hold molecules together and lock them in a place. There is very little free space between the molecules. Particles are closely arranged and regularly in order. Rigid arrangement means particles can vibrate, rotate about the fixed position, cannot move freely without disrupting the whole structure. In principle, solid, liquid, and gas states are interconvertible. So you can see solid can be converted into liquid, liquid can be converted into gas, and vice versa. And those are the names of the process. First, we look at solid. Freezing, solidification, occurs when a liquid changes to solid. Freezing process, when the temperature of a liquid is lowered, kinetic energy decreases, molecules move slowly, intermolecular forces can overcome the motion of the molecules. When the intermolecular forces are strong enough to hold the particles together in a fixed and orderly arrangement, the liquid freezes. I'm quite sure this process you have learned since your lower secondary school. So there is no further explanation over here. Freezing point is a temperature at which liquid and solid phases of substances coexist at equilibrium. Same goes to melting or fusion. Also, you have learned about that. Solid changes to liquid. The rest of the points you have known earlier, so you can read back. Melting point is the temperature at which solid and liquid coexist in equilibrium. Sublimation, where solid changes straight to gas without going through the liquid phase. And this occurs only on solid with big intermolecular forces, for example, like iodine. Okay. Deposition, the process where gases turn back into solid without passing through the liquid phase. All right, this is the type of solid. We have two types of solid. One is crystalline, one is amorphous. Normally, questions asked in exam differentiate between the two types of solid. So I suggest to the students do it in table form. Crystalline solid, a solid that has highly ordered structure where atoms, molecules, ions show a regular repetition in three-dimensional arrangement, while amorphous solid that does not have regular three-dimensional arrangement of atoms or molecules. Crystalline solid form when a saturated liquid is cooled slowly, while amorphous solid form when a saturated liquid is cooled rapidly. In crystalline solid, atoms, molecules, ions occupy a specific position. Example, ice, sugar, salt. While in amorphous solid, the examples are glass and plastic materials. Now, the type of crystalline solid, we have metallic crystals. Metallic crystals are formed by metal. These crystals are made up of atoms of the same element. Thus, they can be packed very closely in three-dimensional structure, composed of atoms of the same metal linked together by metallic bond. The physical property of metal, high electrical and thermal conductivity, luster, ductile and malleable. Go and find the definitions of ductile and malleable. They are in the notes, or you can Google and find out the meaning. I can give you idea. Ductile means the metal can be turned into wires. Malleable means you can reshape the metals. Remold or reshape. Okay, example of metals is sodium, magnesium, iron, and so on and so forth. Ionic crystals are composed of positive and negative ions which are held together by ionic bonds. Physical property, high melting point, hard but brittle, do not conduct electricity in solid state but conduct electricity in molten or aqueous state. For example, sodium chloride. Molecular covalent crystals, that's the third type of crystalline solid, composed of molecules held together by intermolecular forces, either van der Waals force or hydrogen bond. Example, iodine. Number 4, giant covalent solid, very large molecule, huge molecule, gigantic structure, composed of atoms linked together in the large networks by covalent bond. For example, diamond, graphite, silicon dioxide. In diamond, each carbon atom bonded to 4 carbon atoms through a strong covalent bond in a tetrahedral arrangement. This arrangement repeated to give a three-dimensional giant structure. The physical properties of diamond: transparency, great hardness, non-conductor of electricity, very high melting point. This is diamonds, how diamond look like in 3D. And look at the arrangement of atoms. All the atoms are arranged in tetrahedral format. Graphite is an example of layered structure in hexagonal crystalline system. In the layers, each carbon atom is covalently bonded to 3 carbon atoms to form hexagonal ring. The layers are held together by weak van der Waals forces. Physical property of graphite: gray in color, metallic luster, soft, conductor of electricity and heat. This is how graphite looks like. So students can see layer by layer. In a layer, atoms are connected in hexagonal crystalline form, and between the layers there is van der Waals forces.